Well, hi there, kiddos. I hope that you are having a good week. We are going to find slope from a graph today. So we're going to start talking about this thing called slope, which is your rate of change. We talked about that in the last video, but now we're going to talk about how to find it if we have a graph. So there are some steps we're going to have to follow. So if you want to find slope from a graph, step 1, find that's a W. Two pretty points. And what I mean by pretty points are they are exact points. So they are whole number integer points. They're not like halves or in the middle in between two little grid lines. They fall right where two little grid lines intersect. So we have 1, 2, 3, 4, 5 points already graphed on this graph, but only 2 of them are pretty points. This is not a pretty point. You see it's in the middle of a little square, and we don't even know we'd have to guess. This right here is also not where two grid lines meet. It's in the middle. And so is this one. We only have 2 pretty points here, this one and this one. And so step 2, find 2 pretty points and connect them if they're not already connected. If they are connected, fine. But so we're going to connect them. So we're going to create a line and we're going to connect these 2 points with a line. So those 2 points are now connected. Step number 2. We're going to create a right angle between point 1 and point 2. And so what I mean by this is we're gonna connect this point and this point, but we're gonna do it making a right angle. And when I do this, I always do it from the left point to the right point to make my right angle, but you do not have to do it that way. However you see the right angle is fine. I'll show you that it works both ways. I just always tend to do this. So I'm gonna draw my right angle. I go down to here and over to here. So I've made this pretty little right angle. I now have a pretty little right triangle. Step number 3 is going to be to find your rate of change, and we're going to call it the rise over the run. So it's going to be to count the rise and the run. When we find slope from a graph, we always use something called rise over run, because if you'll remember when we talked about this before, when we talked about what slope is, it is the change in the y values over the change in the x values. And we'll talk more about that as we go through the week, because we're going to be doing lots of slope this week in different forms. But from a graph, it's the rise over the run. It's how much do the y values change and how much do the x values change. And that little right angle helps you count it very easy, because what I'm trying to figure out is how far did I have to go down and how far did I go over to get from this point to this point. This is called your rise, the change in the y values. This is called your run. Rise goes up and down, run goes left and right. Okay, so we're going to count our rise over our run. And then we're going to and we'll talk about step 4 in a second. So to do our rise over our run, I'm going to change colors here so it doesn't all blend in. My rise to go from here to here, I went down. So I went down 1, 2, 3, 4, 5. And since I went down, that makes it -5. And then my run happens to be from this corner over to 1, 2, 3, 4, 5, that corner. So my run is +5 because I went right. So my rise is -5, my run is +5. And so step number 4, I'm going to write my slope as the rise over the run. And so in this case, my rise was -5. My run was 5, and then I can simplify that. -5 over 5 simplifies to -1 over 1, or just -1. They all mean the same thing. They all get you to the same point. But what that means, what this tells me, is to get from one point to the next on my graph, I have to go down 1 and over 1 to get there. And so if you look, if I start here and I go down 1 and over 1, I'm at a point on the line. If I start at this point and go down 1 and over 1, I'm again at a point on the line. So let's look at a couple more examples. So now we have another one. Step 1 is going to be to find 2 pretty points. And they have already graphed the line for us, so I will not have to connect them, but I do need 2 pretty points. And it looks like I have a pretty point right here. And I have another pretty point not till way up here. And I told you that I always do my graph, I always go from the left point to the right point, but in this case, it all depends on how you look. When I do from left point to right point, I always do the vertical motion, the rise, and then I draw the run. But I'm going to show you that it works exactly the same if you draw it the other way. So, because I would draw mine, I would go up and then over, but a lot of you will see it this way. You're going to go over, and then you're going to go up to make your right triangle. And I know that that's not very straight lines, but there's my right triangle. I'm still going to count my rise over my run. And then I'm still going to write my slope as a ratio. So I've found my 2 pretty points. I've made my right angle. So now I'm going to count my rise over my run. The rise is the vertical motion. It's the up down. So to get from here to here, I had to go up. So I went up 1, 2, 3, 4, 5, 6, 7. So my rise is 7. And over here, I went over 1, 2, 3. So my slope becomes up 7 over 3. And so that's my rise over my run. This does not simplify into something nice and neat. 7 over 3 is perfectly acceptable. This is also the reason, by the way, that I told you way back in the beginning of this class that you wanted to leave fractions as improper fractions. Because if you write a slope of 7 over 3 as 2 1/3, that is going to tell you absolutely nothing. It needs to be an improper fraction because it's a ratio. It compares how much did I go up and down over how much did I go left or right. Okay, so let's do another one. So now here's another graph. Step 1, find 2 pretty points. So I've got a pretty point here and I have a pretty point here. And so we're going to draw our right triangle. And so I'm going to connect here, so I'm going to go down and then over. So there's my right triangle, or my right angle, and then I'm going to count my rise over my run. Well, my rise happens to be 1, 2, 3, 4, so I went down 4. So my rise is -4. My run is over 1, 2, and I went right, so it's positive. So my slope becomes -4 over +2, and if I simplify that, it becomes -2 over 1, which is just -2. They're all acceptable. Simplest form is always better because this means to get to one point to the next, I have to go down 2 over 1, and if you look, if I go down 2 and over 1, I'm at a point on the graph. And so simplest form is always better. It puts your points closer together. But -4 over 2 is the same thing as -2 over 1. They'll both get you to the same place. So now look at this next one. Now I have this vertical line, which we have talked about, by the way, is not a function because it has x values that repeat. It's what we use when we do the vertical line test. But we want to find the rise over the run for this. So the step 1, find 2 pretty points. Well, there's one here and there's one here. And those are not the only 2 pretty points, but there's the 2 I'm going to use. Step number 2 says to make a right angle connecting those. Well, I can't make a right angle connecting those because they are connected by a vertical line. So there's no right angle to be connected. Okay, what I do have is vertical motion between the 2. Right? They are connected by a vertical line. What I don't have is this part of the triangle, the horizontal part that would make the base. So that's going to be important in a minute, and we'll talk about that. But so here's what happens. So my rise, and it wouldn't have mattered which 2 points I use. Your rise will be different no matter which 2 points you use, but my rise for the ones I chose happens to be a change of 1. And you could say 1 or -1. Either way, it's not going to matter. But there is a change of 1 from here to here. So there's a change of 1. But there is no run. I didn't go left or right at all, which means run has to be 0 because I didn't go left or right at all. And so here's what happens. If you put into your calculator this ratio or this fraction and you want to simplify it or you want to divide that out to find out what it equals, if you put into your calculator 1 divided by 0, it is going to come back and give you an error, and it's going to tell you error undefined. The reason is division by 0 is not something we can do. It is not a skill we have. And it's not just because you're in Algebra 1. We cannot divide by 0. Because if you think about what division means to take this top number and split it into this many groups on the bottom. I cannot take a whole and split it into 0 groups. I cannot take something and split it into nothing. I can take nothing and split it into something because then everybody doesn't get anything, but I cannot take something and split it into nothing. This is not possible. So when this happens and you end up with a 0 in your denominator, what you get to say is this slope is undefined. And here's the big reason why. This is a vertical line. It goes up and it goes down forever. We don't know really which one it's doing. We don't know if it's going up or going down. So we can't say whether this line increases or decreases. So we can't look at it and say, oh, it has positive slope or oh, it has negative slope. We just know it goes up and down forever. We don't know which because it does both at the same time. And if you were to try to ski down a mountain that looked like this, that'd be quite scary because you just fall off the mountain because that slope is too steep to ski down and you just can't do it. So the slope of a vertical line is always going to be undefined. Now we have a horizontal line. So this line is going to go left to right. We're still going to do our 2 pretty points. So I'll pick this one, and this time I'll pick one way over here. And we're still going to find our rise over our run. But again, I cannot make a right triangle. So I'm not going to make my right angle. I am, however, going to talk about my rise and my run. It does not rise at all. This line does not go up or go down. It simply goes left to right. So this has a rise of 0. And in this case, it has a run of 1, 2, 3, 4, 5. Well, unlike the previous problem, I can take nothing and divide it into 5 equal groups because then everybody gets 0. I can divide 0 by a number. I just can't divide a number by 0. This is acceptable. This has 0 slope. So this takes us back to our Hoy and our Vux. Horizontal lines have 0 slope, and they have 0 slope because there's no rise, and they're always in the form y equals. This one, vertical lines, have undefined slope because they go up and down and they have no run, and they are always x equals. So let's do another example. Let's just talk about, we're going to find a slope and then we're going to talk about what it means. So we have a graph. Step 1, find 2 pretty points. So I have a pretty point here and I have a pretty point right here. Now you are going to have to pay attention to the spacing on your graph before you do this. If you look, this goes 0, 2, 4, 6, 8, 10, 12. So every time you go up a line, it is increasing by 2. That is going to be important when we find our rise. Your run is okay because the scale down here goes 1, 2, 3, 4, 5. It counts by 1. But the scale on the y-axis counts by 2s, and that will be important. So to find my rise, it looks like I went up 2, 4, 6 because each one of these counts for 2. So my rise is going to be 6 units. My run is going to be 1, 2, 3, 4. So my rise over my run is 6 over 4, which simplifies down to 3 over 2. Which, if you want to be real technical, is 1.5. And so now we want to talk about what this means. What does it mean in this situation? Well, if you look at our graph, the y-axis is labeled as our salary by our hourly rate, and our x-axis is labeled by years of service. Well, since our slope is the y over the x, because it's rise over run, we have to label it as y over x. So right now what it means is that it is my hourly rate. Let me have some space here. It's my hourly rate, because that's y, over my years of service. Okay, and it is an increasing graph. It's a positive slope. So what this means is that my hourly rate increases, and since we're talking an hourly rate, we're going to take this 1.5 and turn it into $1.50. Increases $1.50 for every year of service. So every time I work an extra year, I get an extra $1.50. So when I work from 1 year to 2 years, I get a $1.50 raise. Then when I make it to my 3rd year, I get another $1.50 raise. And then when I get to my 4th year, another $1.50 raise. So every year that I work, I get an extra $1.50 raise. That's what happens. So that's what it means. And we figured out by looking at our graph and doing y over x. So now let's go backwards. Now it says to find 2 points given a point in the slope. So we're going to graph our point, and then we're going to use the slope to find 2 other points. So we're going to graph this point, -4, 3. So we're going to go over to -4 up to 3, and we're going to graph that point. Now it says to find 2 different points using the slope. Well, we know the slope is -4/5, which means that from this point to get to another point, I have to go down 4 and to the right 5. So I'm going to go down 4, 1, 2, 3, 4. And then from there, I'm going to go to the right 5. 1, 2, 3, 4, 5. So my other point is right here, which looks like is at 1, -1. You can also go backwards from this. Instead of going down and to the right, I can go up and to the left. It's going to do the same thing, and just I'm going to apply the negative going left instead of going down. So to find another point, I'm going to go up 4. 1, 2, 3, 4. And then I'm going to go left 5. 1, 2, 3, 4, 5. So there is another point which looks like it is at -5, 6, 7, -9, 7. That would be another point. Now, those do not have to be the 2 points you pick. You could have gone down 4 and over 5 from here, and then from this point you could have gone down 4 and over 5 again and kept on going. But I wanted you to be able to see that you could go backwards and do it the opposite direction as well. It still works. It still gives you the same thing. So that is finding slope from a graph. You will practice this when you come to class tomorrow, and I will see you guys next week.